Scientific notation is a straightforward way of writing numbers using exponents. Now, what's interesting about scientific notation is it's designed to be used on really big and really small numbers so that you don't have to write all those zeros and all those commas and things like that. But it's sometimes harder than it needs to be. The concept of scientific notation is that you're going to write a number that is a product of two other numbers. Product means you're going to have a multiply sign in your final statement, in your written number. You'll have a number on the front side, which is called a coefficient. That number is always going to be between 1 and a little, like 1 and 9.9 repeating, or -1 and -9.9 repeating. So it's going to have a particular range it has to be within, and then you're always going to have a base of 10, and then always you're going to have an exponent that is an integer. It could be positive or negative, or it could be a 0, but it has to be no decimals. It has to be an integer. And to do this, we're simply going to count. So let me show you an example. The first number I have here is 32. 32 is rewritten as 3.2, right? It has to be between 1 and 9.9 repeating. So I bring the decimal from the original location just over one spot. And when I bring it over one spot, I'm going to add my times 10. And I'm going to actually stop because I have one decimal place move. So I'd put a 1 right up there. Now you might remember that 3.2 times 10 to the first and 3.2 times 10 is the same thing. So either one of these would be successfully and correctly written scientific notation problems. But I bring this up because the second example is just ever so slightly different. My decimal's at the end because I don't see it. And to get it into position to be 3.2, I have to move it twice. So guess what? 10 to the second. And if I had a bigger number still, I'd imagine 1, 2, 3, 4. So 3.2 times 10 to the fourth. Keeping in mind the first number always has to be between 1 and 9.9 repeating. The second piece always has to have a times sign. Third piece always has to have a 10. And the exponent always has to be an integer. On the smaller side, I use 32 just to keep it consistent. This time it's too small. My first number always has to be between 1 and 9.9 repeating, and this one's less than 1. So I'm going to move the digit the other way, making 3.2 again, still the times, still the 10. But the only difference here is, since I moved it the other way, I'm going to go ahead and do a -1. And you might try to remember this. If you see negatives, that means you have a small number, like 0.32. And if you have a really small number like 0.0032, I need to move my decimal 3 spots to put it in position. So you can guess times 10 to the -3. And I'll circle them because that indicates we're done. And that is how you work with scientific notation.